We're doing AP review. This is 2017 AB Free Response 2. When a certain grocery store opens, it has 50 pounds of bananas on display table. Customers remove the bananas from the display at a rate modeled by F of t, and then they give us a formula for F of t from times 0 to 12, where F of t is measured in pounds per hour, and t is the number of hours after the store opened. So, important to note, this is a rate in, rate out problem. So the rate the bananas leave the stand is F of t, right? And it's from 0 to 12, okay? After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by, oh look, it's the rate in, right? So people are adding bananas at a rate of G of t, and I have typed both these in my calculator, but I'm too lazy to write them down. So after the store's been open for 3 hours. Cool. G of t is also in pounds per hour, and t is the number of hours since the store opened. Okay, so rate in, rate out problems. We've seen these a bunch. It doesn't matter if it's putting bananas on a display and taking them off, or shoveling snow while snow falls, or getting in line for an escalator and getting off the escalator, or getting in line for an amusement park ride or getting off the line, or pouring water into a container while water also leaks out of the container. Rate in, rate out problems are pretty common. All right. Part A, how many pounds of bananas are removed from the display during the first 2 hours the store is opened? So, if we want the amount removed, right, if we have the rate that they were being removed, then to find the amount removed, we're going to integrate that rate. And they said for the first 2 hours, so from 0 to 2. Since they called it F of t, you just have to call it F of t and then find the value, right? So I already put them in my calculator. I put F of t in as y1 and G of t in as y2, right? So I put F and G in my calculator, right? In order to do this, again, you don't show the AP this, but you need to know how to integrate. So you're going to do function integrate, that's math 9, y1 with respect to x from 0 to 2 and get an answer, right? So you're going to press math 9. You're going to go to vars over to yvars and pick function y1, comma, with respect to x from 0 to 2 and hit enter and hopefully get the number of bananas that were removed. 20.051, and that's in pounds of bananas. So 0.51 pounds of bananas. Cool. That's how many were removed. That's a lot of bananas, man. All right. Cool. Part B. Find f prime of 7 using the correct units. Explain the meaning of f prime of 7 in the context of the problem. So, find f prime of 7, right? This is another one that my calculator can do for me, right? F prime of 7 is going to be a thing that I type into my calculator, right? There are two ways to do this. You can either do n derive, which is math 8, of y1 with respect to x at 7, or you can second calc, pick dy dx, and then hit 7 for your x value and hit enter. Either of those are fine, right? So if you do it on a graph, it can take a little longer if you weren't planning to graph. I personally like the math 8 option, but if you were going to do the graph option, you'd do second calc, and then you'd pick dy dx, and then you just enter the x value that you want. I like my math 8 option, so I'm going to pick it. Vars over to yvars, I pick function y1 with respect to x at 7 and hit enter, and I get negative 8 point either 119 if I truncate, or 120 if I round, right? Now, so if f is in pounds per hour, right, then this is pounds per hour squared, right? Pounds per hour, right? So you can either say pounds per hour, or you could say pounds per hour, right? Okay, and what this means is this is the rate of change of the rate, meaning the rate that they are being removed is decreasing. So what this means is the rate bananas are being removed is decreasing, right? It's decreasing at that rate of 8.119 pounds per hour or 120. Notice I didn't say decreasing at a negative rate because that would actually be a double negative, right? So the decreasing is covered by that negative. Okay. And again, pounds per hour is one way to write it. You could also write pounds per hour squared. They mean the same thing. All right, part C. Is the number of pounds of bananas on the display table increasing or decreasing at t equals 5, give a reason for your answer. Okay, so now is the first time I'm actually going to have to worry about that rate in, right? So the trick is that the number of bananas is not just involving f or just involving g. So I'm gonna make my own notation and just say that b of t is the number of bananas, right? Right, and this is my own like Hogan notation. I wouldn't on the AP. You shouldn't just invent things on your own for credit, but if it helps you quantify something better, it's okay to make a note of that. That means that the rate of change of b of t is going to be the rate in, the rate bananas are being added, which is g of t, minus the rate out. And we see this happen a lot where they ask us to find the rate of change of something when there's a rate in and a rate out. It's going to be the rate in minus the rate that we're losing them. So b prime of 5 would be g of 5 minus f of 5, right? And I can find that in a couple different ways. So you could either actually find the values for g and f at 5, which is fine. You could also in your calculator, since you have a y1 and a y2, if you want, you can actually hit enter on both of those, and you can make y3 you could make it your y2 minus your y1 if you want. That's an option. So there's some different choices, right? So so I go to vars, and I'm going to go ahead and pick y2 minus vars function y1, right? And then the cool thing is if I hit graph, right, and I think I turned both of them off. I did, so now I only have the one that's subtracting. And I can actually go ahead and find the value at 5. I could have also used the table function. That's fine too, right? So when I plug these values in, I'm going to get that this is a negative. So if we hit trace, right, if I hit trace and then 5, enter, it'll take me to where the function is, and it's a negative 2.263. Right, that's the value, which is less than 0. So since g of 5 minus f of 5 is less than 0, the number of bananas is decreasing at t equals 5, right? Because again, that's the rate of change of the number of bananas, right? And so if it's negative, that means the number of bananas is decreasing. Last one, how many pounds of bananas are on the display table at t equals 8? So, we can actually erase this guy. So, in my brain, the easiest way to do this, right? So, if I want the number of bananas at t equals 8, right? I know that the number of bananas, this is my part D, right? I know that the number of bananas is going to equal the number of bananas that I started with, or the pounds of bananas that I started with, which were 50. I believe at the beginning of the problem they said we started with 50, right? Plus the amount of bananas I gain. Well, the number of bananas I gain by t equals 8, I'm going to gain the ones starting at 3 when they start stocking up until 8 of g of t, right? That's how many bananas I'm going to gain, minus the bananas that I lose, right? And the bananas I lose are the integral from 0 to 8, because people started taking the bananas right when the store opened, of f of t dt. So essentially, this is what I need to find my number of bananas. I'm allowed to let the calculator do the hard work. I can type this in, right? I can type 50 plus function integrate y2 with respect to x from 3 to 8 minus function integrate y1 with respect to x from 0 to 8, right? The AP doesn't care about the calculator notation. You just have to be able to get it right. And then when I do all of that, I skip from here to here, I type that in, and I get that it is 23.347 pounds, right? So again, these problems very frequently boil down to the amount you started with plus the amount you gain minus the amount you lose. Oh, and that says loose, by the way, because my brain is tragic. It's cool. I meant lose, not loose. Everybody has a bad moment.